The objective is to illustrate a conceptual design and to model a convolutional cognitive neural network artificial intelligence algorithm as it is presented in this video. Backpropagation used in artificial neural networks to calculate a gradient that is needed in the calculation of weights to be used in the network. It is commonly used to train deep neural networks with more than one hidden layer. It requires the derivative of the loss function with respect to network output to be known, which typically means that the desired target value is known. The learning algorithm can be divided into two phases: propagation and weight update. Phase 1 is propagation. Each propagation involves the following steps. 1. Propagation forward through the network to generate the output values. 2. Calculation of the cost. 3. Propagation of the output activations back through the network using the training pattern. Target to generate the deltas, which is the difference between the targeted and actual output values of all output and hidden neurons. The neural network algorithm corresponds to a function which, given a weight, maps an input to an output. The optimization takes as an input a sequence of training examples and produces a sequence of weights, starting from some initial weight, usually chosen at random. These weights are computed in turn. First, compute using only 4. The output of the algorithm is then given a new function. The computation is the same in each step. Calculating from is done by considering a variable weight. Convolutional neural networks are networks that use many identical copies of the same neuron. This allows the network to have lots of neurons and express computationally large models while keeping the number of actual parameters. Convolutional layers work on higher dimensional data also. In fact, the most famous success of convolutional neural networks are in applying 2D convolutional neural networks in order to recognize images. In this code, the list sizes contains the number of neurons in the respective layers. To create a network object with using the NUMPY NP random rand_n function to generate the Gaussian distributions with mean 0 and standard deviation 1. This random initialization gives our stochastic gradient descent algorithm a place to start. Backpropagation used in artificial neural networks to calculate a gradient that is needed in the calculation of weights to be used in the network. It is commonly used to train deep neural networks with more than one hidden layer. It requires the derivative of the loss function with respect to network output to be known, which typically means that the desired target value is known. The neuron transfer. Once a neuron is activated, the need to transfer the activation to see what the neuron output actually is. Different transfer functions can be used. It is traditionally to use the sigmoid activation function, but you can also use hyperbolic tangent function to transfer outputs. The sigmoid activation function looks like an S shape. It's also called the logistic function. It can take any input value and produce a number between 0 and 1 on the S curve. It is also a function in which you can easily calculate the derivative, which is the slope,